Hello everyone, so this is the demo for our CSD project where we have built a computer system using the Zygo board. Here you can see the connections. This is the HDMI cable that is being connected to the display, and this we are receiving from the system. Also this cable is used to power the board and program it, and here through this system keyboard is connected, which will be connecting this display. This keyboard is used for the whole system, and here this white cable that is used to power the display and program it as well. So now we can see in the display that the OS login is being shown. So when we type root, so we can get the Peter Linux OS host. So now when we cd into the folder that we have, so here when we are into the folder, now we will run the script.
So as you can see, we have one screen, this is one Zygo board and one host system. So our implementation basically works like that. So we will send our source code from our host system to the Zygo board using SSH connections. Now Zygo board has two processors, one is ARM processor and one is programmable processor. So what we have done is, since our compiler and VM and everything is compiler, VM and assembler are in C++ or Python, so we have actually used our ARM processor to execute those commands, but the final bitcode that is being generated will be simulated here on Vivado, but will be running on this programmable chip. Like we have customly loaded our processor into this chip, and the bytecode machine code that will be generated will be run here. So we will show you a demo where we will put the code into this home screen of host system, as you can see. Now we will just in this command line interface, we will write some commands, save and then send. So now we can see that we have used a save command to save this code into a file, and then we are using send command to this particular IP, which is being given to our Zygo board via this Ethernet cable. So we are sending it to this IP. Now using SSH command, it is being sent to our system, as you can see in the screen. By using the ls command in user folder, we have our code. So now we have to just run a simulation into this host system. And it will generate our, so as you can see, we have our code here. Now we will be running our simulation and basically our entire pipeline and generate the bytecode. Yeah, so this is our script, that is script.sh. Now we will be running it. Now the script will first of all install all the dependencies that are there, for example Bison, Flex, and it will also install any other dependencies, maybe let's say any Python libraries. And after all that, it will first compile it, then it will the compile code, the tree address code will be sent to virtual machine, and after that it will be sent to assembler, and finally the assembler will be 01 bytecode. So as you can see, our YARC and flex code has started, and the compilation of the program has started. After this, there will be VM and assembler code that will also run. Now we can see that this is the machine code, quotient, pop, commands of stack are there. After this, now it is again asking us permission to send the data back to the host Linux system. Now this is the user password of host system. You can't show the password for security reasons.
So now you can see that whatever the assembler code that was generated, so here it will be loaded automatically into the RAM data file, and it will be refreshed automatically. It ends with a no-op instruction that has all the 00s at the end to get the memory dump at the end of the execution of the simulation. So now if we go to the simpute.v code, we can see this is the code, and now we will run the run simulation.
Now simulation will take some time to run.
So now the simulation is completed, and we can see the input and output values of the CPU.v5. And if we go to the terminal and get the output of the code that we run, so here 7 is the output of A plus B, and 3 is the output of A, and A is printed at the end of it.
Now this virtual display also works on the concept of a real display. It regularly updates its screen value to a particular memory location. So we have in our entire memory location, we have dedicated some bytes from in one fixed range. Now it is reads from that range. It checks the data type, and according to the data type, it prints the value. For example, if 0 is for integer and 1 is for character. So if it is reading 0, it will convert that ASCII value to integer, that byte value to integer, and it will just print that. Otherwise, it will use its ASCII value. Let's say A is there, so for that it will work like this.
Of a new file where we are giving A and B as input, and if it is checking whether A is less than B or greater than B, we are sending the file again to the board, running the complete pipeline, and sending back the RAM data here, and running the simulation again. So the simulation is now complete for less than greater than program, and now we are again going to the. So this is the final output that we get after running the complete pipeline. Now we ran the program whether the number 4 is a prime number or not. So here one more thing to consider is the state will reach E. This is state it will reach at the end of the execution of the program. So here in the output you can see that 4 is going into the loop, and it is printing it is not a prime number.
So now we move to a more complex program. So as you can see here, this is a program where we have two values A and B. Then we have a lot of print statements in between. After that, what we are doing is we are checking that for each number, like for 1 we are adding the numbers, for 2 we are multiplying them, or for 3 we are doing an AND operation, So we can see we have loops here, we have switch case statement here, we have print statements, and the output of this is this. After getting the simulation, we can see that wherever we have used backslash and a new line is coming, calculation are correct, 40 plus 60, 40 into 60 and 40 and 60, all the values are correctly shown here. So as we can see that we have also implemented a quite non-basic program using loops and conditions. Thank you.